Hey everyone, welcome back to new video. In today's video, we are going to solve rat in MS problem 1, and today's problem of the day is some tricky but concept is easy. Most of them fear about this such type of problem. Okay, so to understand it easily, watch till last end. And in this video, first we explain the problem statement, then we explain the approach with using flowchart, and also I will explain using a example, and last we also explain the code with the complexity. Okay, and before starting today's video, please like and share, and if you are new, please subscribe. Your subscribe motivating me for future contents. Okay, go to problem statement. In problem statement, we have given a matrix, and consider a rat is placed at 0 comma 0 index. Okay, means it is at the 0 comma 0 means it is 2D matrix. There 2D matrix using, so 0 comma 0 means this first position. Okay, and it is a square matrix, mat order n into n. Okay, matrix elements all sizes n into n means n square, and it has to reach the destination at n minus 1. Okay, means red source address is first position and destination is the last cell. This cell is the destination. Okay, n minus 1. Okay, now find the all possible path that the rat can take to reach the from source to destination. Okay, we have to find the path how can the rat can reach destination from source address to destination address. We have find that path only. Okay, this is the our goal, and the direction in which the rat can move up and down, left and right. Only this four direction rat can move. And value 0 at a cell in a matrix, it represent that it is blocked, and rat can't move to while value to it, and while value is 1, then metric represent that rat can travel through it. Okay, it means if any of cell value is 0, if any of cell value is 0, then can't move because that path is not for routing. If any cell value is 1, then rat can move that path. Okay, and in path no cell can be visited more than one time, and if source cell is 0, that the rat can't move already said, and in case no path find, then return an empty list, and driver code will output minus 1 automatically, will handle by driver code. Okay, fine. Now go to example, we can easily understand. In first example given a 2D matrix, this is a 2D matrix, and 2D matrix size is always n square. In this 2D matrix size is n into n, n into n. They have given size is n into n, means n square. Okay, now in this first we have find the source address is 0 comma 0. Okay, 0 comma 0, it is source address, and we have to reach n minus 1 or destination address. Now rat is in this position 0 comma 0. Okay, this position. Now we can move up and down and left and right. So if we move this path, now rat can move down, downside, because right side are value 0, so it is blocked. Now it will be moved from down, this side or this side down. Okay, now we are in now this side. Rat is now in this position 1 and 1. Now rat can move this position, or rat can move this position. Then after reaching this position, rat can move from this one right side, and from this side there is no path, all are blocked because all are 0, you can see. Now rat can move in down, then rat can move this right, then we rat is reach destination address. Okay, in this path. Now in this example, how many path we can reach our destination address? We can reach two path, like okay, first first path is down, this down, 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 right. Okay, down address, down, down, right. This right. Then again down, then again right, then again right. This is path one. Okay, how many paths? This one, this one, this one, this one, this one. Okay, this is now will be write down. First we down, then we again down, down, then we move right. Okay, right, then again down, then again right, right. So right, right. This is our first path. This is our first path. Now second path. Second path is second path. Second path is from source address. Okay, then we move to down. Okay, fine. Down. Then we move to again right path. Right path. Then again down. Then again down. Then again right. Right. This path. Okay. I repeat again. First we first we go to this path, this source address, then we go to down. Okay, fine. Now we are in this position. Rat is now this position. Now rat will move right side. Then rat will move down. Then rat will move again down. Then rat will move right, right. Now reach destination. So second path is down, down, right, down, right, then down, down. Two times down, then two times right, right, right. Okay, right, right. This is our second path. Now, in output, show these two path. In output will show two path. You can see DDR, DDR, DRR. Okay, DRR. Okay, and second path is DRD, DRD, DDRR, DDRR. Okay, this is now go to next example. In next example, given this matrix and our source address is this and destination address is this, but in this case you can say our destination address is 0, so means it is blocked path. This path is blocked, we can't reach this destination address. So for this we can't reach our destination, there is no path, you can see no path to reach destination. So for this it will return -1 because in our problem statement they given that if no path find then will return -1. Driver code will handle this. Okay. Now explain the approach with flowchart. Now in this flowchart you can see first we start the operation. Okay, then we check if cell is blocked or not. Okay, if cell is 0 value then it is blocked, so we will check that it is cell value is equals to 0, then it will be blocked. And then we initialize three variable, one is path, one is visited, one is directions. Okay, then we use the recursive dfs function, and using this dfs it will check if x and y is the destination and add to path, and it will add to path. Okay, then we mark the current cell visited, then we explore the direction, and our direction is four direction: down, up, right and left. Our given we have moved four direction only. And then we check if new cell is valid and it will be within the bounds, not blocked, not visited. Okay, and if valid then recursively call the dfs, then we use the backtrack to unmark the current cell as visited. After that we call the dfs from with, then we solve this using this calling dfs, then we return our path. Okay, return our path and it will end. That's it. Now go to code. First we define a function, is it is safe or not. Okay, and it will check, using this it will check if x and y is within the matrix bound. And matrix bound means if it is blocked or not, it will check this. So for this we written this line. Okay, then we if create a if condition to check the destination is reached or not. And if it's reached to a destination, then it will return the path to the path list. Okay, and after that we mark the visited cell, which cell are visited, then we mark that current to current cell. And after that we explore all the four direction. So we create this for loop. Okay, up and down, left and right. Okay, for up and down, left and right, we will traverse this possible direction. Then we use backtrack function, and is it is unmarked the current cell. If it is visited, then we check if it is start cell is blocked or not. Okay, it is a, then if there is no path find, then it will return the empty list. That's it. Now in part 2, next part is, okay, next part we store the possible path, how many paths we can reach our destination address. We calculate the possible path. So we initialize this path. Then we create a 2D list to keep track all visited cell within this range. And then we create a possible movements like our direction, four direction, down, up, right and left. Okay, and after that we start the DFS from with an empty path, and then we return the paths. Now what is the time and space complexity? And in this problem, time complexity will be O of 3 n square to the power n square. Why? Because each cell can lead up to 3 possible moves, and excluding the direction from which it came. And also there are n squared cells, and the size is matrix size is n square. Okay, and for this the exponential growth of possible paths will be O of 3 to the power n square. Okay, and space complexity will be O of L into X. Here L is the length of the possible paths. L is the length of the possible paths, and X is the store all path. This is the path. Okay, possible path. And so for this space complexity will be each path can be up to steps L steps. So for this space complexity will be L into X, L into X, O of L into X. That's it. Okay. Now go to code and now compile and run. I have shared this code link in description and already explained. So now submit. Okay, we solved today's problem. Hope so today's video is helpful to you. See you next video. Till then, tata, bye bye.